Hello guys, thank you for watching this video. Currently any sounds that you hear are just me moving around my surface. So for linear interpolation, this was very confusing for me at first, but here are the key points that you want to do, since with linear interpolation you're trying to find the value of, this is usually in thermodynamics, the value of a thermodynamic property when the values are not tabulated. So over on the left you'll see just a little snippet of a table that I took from the Fundamentals of Thermodynamics by Bornak, I think that's how you say his last name, and Sontag. And let's say that I want to find the pressure at 32.7 degrees Celsius, which should exist since it's right in between 30 degrees Celsius and 35, but we don't have that value tabulated. So to approximate, we use linear interpolation. So first, let's define our variables. So if we want to find our pressure, I'm going to use blue for that actually. If we want to find the pressure, that should tell you that that is going to be our y value. So that's our unknown. And our known value that we're working with is this 32.7 degrees Celsius, but it is untabulated. So that's going to be our x value. So if I just work on my x variables for now, and I'll work on the y variables later, we'll see that for x1, that's going to be our smallest tabulated value, and the smallest tabulated value you'll see is the 30 degrees Celsius. X is our untabulated value, which is the, we can say, variable of desire, or not variable of desire, but number that we're trying to work with, the value that we're working with, which is 32.7 degrees Celsius, and x2 is our larger tabulated value, which is the 35 degrees Celsius right there. Now with our y variables, only two of them are going to be known, which are our tabulated ones. So y1 corresponds with x1 being the lowest tabulated value, and that is going to be that 4.246 kPa. Y, which is supposed to be in between y1 and y2, is our unknown. And y2, that is our higher tabulated value, which is going to be 5.628 kPa. So before we move forward, we can make informed decisions or informed guesses, because if our x value that we're working with is right in between 30 degrees Celsius and 35 degrees Celsius, then we can expect that the y value that we get should be in between 4.246 kPa and 5.628 kPa. If we have a number that is below or above either of these already tabulated values, then we know that we did our calculations incorrect, and that will likely be due to calculator misfunctions in case you put it in incorrectly in the calculator. So our next step is to plug it in to the equation. Okay, so y equals, let's write that again, y1 plus x minus x1 over x2 minus x1 times y2 minus y1. Okay, so y1 is 4.246 kPa, kilopascals. X is 32.7 minus x1, which is 30 degrees Celsius. X2 on the bottom is 35 degrees Celsius minus 30 degrees Celsius times, these are y values, y2 5.628 kilopascals minus 4.246 kilopascals. And I'm actually just going to move that off to the side so I don't need to scroll over so much. Okay, this is something that I really want you to notice for now, is that if our goal is to find the pressure, then our final answer should have units of pressure. the way that we can look at that, so right here we've got KPA. And remember, the only way that you can add two numbers together is if they are of like terms. So if this is in KPA, we'll check if this section right here is in KPA. Well, look right here. We've got kilopascals right here. Let me put proper notation this way. We got kilopascals right here. And we've got a degrees Celsius here and a degrees Celsius there. But because one is in the numerator and one is in the denominator, they actually cancel each other out. And so we are left with KPA and KPA here. So in fact, both of these are like terms, and we can actually go forward and solve this. And I already have the answer done, and it equals 4.99228 kPa. And at this point in thermodynamics, your teacher shouldn't be too worried about significant figures, but if they are, then just adhere to those rules. But 4.99 or 5 kilopascals will be your final answer. Okay? And if you want something that is a little less drawn out and just going straight through the problem, I will link my other video to this so that you can see just a rundown of how to solve the problem without me having to explain it. Alright, I hope you guys enjoyed this, like it if it helped you, and you guys have a wonderful day.